Hello, my name is Mr. Asprey and I've done it. I have created a full predicted paper 2H for the Edexcel IGCSE. I've made 30 questions on 30 topics, all written by me and based on most of, but not all of, the topics that didn't come up in paper 1. And you can download it right now for free in my Google Drive, link in the description. And I want you to complete the paper first. And warning, it is tricky. I have made it challenging on purpose. And once you've done that, give it your best shot and then come back and watch the solutions. Quick disclaimer, of course, that I have to make is that I don't have a crystal ball. I can't see into the future. Make sure that you revise thoroughly as many topics as you possibly can. And just use this paper as one helpful tool to support your preparation for paper 2. Now, if you find the paper helpful and you want to help yourself even more and support me too, then I've got you covered by checking out my live revision session where I'm going to be going through 2 more predicted papers in full. So the response to my paper 1 session was amazing. I got lots of 5-star reviews. Students said that it was great value for money and that the resources were excellent. And overall, just really satisfied with the live session, which is great. And that's because you will get 2.5 hours of live teaching, me walking through every question, a chance to ask questions as you go, and then after the session you'll get a recording of the session, full written solutions to all 60 questions, plus video solutions to all 60 questions as well. Now, tickets are going fast, so I've sold over a third even before I've released this free paper onto YouTube. So get involved while you still can. And if it is already sold out by the time you're watching this, or it's actually happened, don't worry, you can still purchase a recording of the session along with all worked and video solutions. Okay, right, I think that's it from me. Let's get that grade 9. You've got this. Enjoy the paper. Here are the solutions coming up. See you later. Okay, let's get it. 3 hours, 30 questions, 150 marks. Subscribe. Good idea. Okay. Number 1, prime factors. So we've got P, it's given as prime factors. Q is given as prime factors. It says find the highest common factor. Give your answer as a product of prime factors. Well, for the highest common factor, we need to only look at prime factors that they share. So they share a 2, so therefore for the highest common factor it will be 2 to the lowest power, so 2 to the 5. Okay, they also share a 3, and again it's to the lowest power for the highest common factor, and they don't share a 5 and they don't share a 7, so that's it. That is the highest common factor as a product of prime factors. Now the next one says the lowest common multiple of 5p and 2q. Okay, so for 5p, we're just going to times through by 5p, so it's going to give you an extra power of 5. So it will be times 5 to the power of 3. And for 2q, we're going to times through by 2, so this will give you an extra power of 2. So it'll be 2 to the 6, 3 to the 4, times 7. And now it's asking for the LCM. Now LCM is different obviously to the HCF. You have to look at every single number, so not just the numbers they share, but every number. So here, the 2's, the highest one is 7, so we have to pick the highest power. Then we look at the 3's, and we have to pick the highest power, so that's 3 to the 4. And then we have to look at, like I said, every single number, not just the ones they share, but there's a 5 there, and that's the highest power will be 3 because it's the only power. And there's also a 7 here, so we have to also multiply through by 7, and that's the lowest common multiple. Okay, it says find the smallest number a such that AQ is a square number. Okay, so let's have a look at Q. Right, Q is this, so it's 2 to the 5 times 3 to the 4 times 7. So let's just write it here. Q is equal to 2 to the 5 times 3 to the 4 times 7. Now, in order to be a square number, you must have your prime factors must be raised to even powers. So, for example, 100 is 2 to the 5 times 2, 2 to the 2 times 2 to the 5. And because those powers are even, that means I can split it up into 2 times 5 times 2 times 5, which is 10 times 10, which makes it a square number. So, I propose that A needs to be 2 times by a 7, so 14. And the reason for that is that when you times these two together now, you're going to add these powers. So you're going to have 2 to the 6, and you're going to have 3 to the 4, it's going to stay the same, but you can have a 7 times a 7, which is going to give you 7 squared. And this now allows us to split it up into two numbers that are exactly the same times together, which is what makes it a square number. So you see how what I'm doing now is I've split up AQ so that it's two numbers times together that are exactly the same, and thus that makes it a square number, and the answer is 14. Okay, classic fractions question. We are going to take this first number here and we're going to write it in terms of fifths. So there are 5 fifths in a whole, so there are 20 fifths in 4 wholes, plus 1 makes 21 fifths. So you just do 4 times 5 and then plus on the 1. And we'll do the same here, we'll do 2 times 7 and then plus on the 1. So that gives us 15 over 7. And then when we're dividing fractions, we flip the second one over and we turn it into a multiplication. So it becomes 7 over 15, like so. And then next we could try and cancel as much as possible. So what we could do is we can divide this by 3 and this by 3, which will give us 7 and it will give us 5. Okay, now we can multiply the top by top and the bottom by bottom. We can't do any cancelling here because to cancel you have to have something on top and something on bottom. You can't have like two things on top, those 7s won't cancel. You have to multiply them together here, and then 5 times 5 is 25. And then how many 25s go into 49? Well, nearly 2, that would be 50, so it's only 1. And what's left over is 24 25ths. Perfect, and that's our final answer. Okay, probability. A biased 5-sided die has the probabilities as shown. The probability of landing on 1, 3, 5 are in the ratio 2, 3, 5 respectively. Okay, so let's work out the probability which is left to be shared up. So we know we've got 0.25 and we've got 0.15. So that means that there is 0.6 which is still yet to be split up. Now this ratio here, that adds up to a total of 10 shares, because we do 2 plus 3 plus 5 is equal to 10. So we can say that 10 shares is equal to 0.6, because that's the probability that needs to be divvied out. So therefore 1 share is equal to 0.06. So the first slot has 2 shares, so times that by 2 gives you 0.12. 3 shares, I need to times that by 3, so that gives me 0.18, and then 5 shares, times that by 5 gives us 0.3. Okay, great. Now it says the die is rolled 300 times, work out the estimate for the number of times the die will land on a prime number. Well, the probability of a prime is equal to the probability of getting a 2 or a 3 or a 5. So that's 0.25 for the 2 plus 0.18 for the 3 plus 0.3 for the 5. Add those together and we get 0.73. So if we're going to do it 300 times, we would expect to get the amount of rolls multiplied by the probability, And this is going to give us, calculator time, 300 times 0.73, 219. Perfect. Okay, the results of a maths test are as follows. Class A had a mean score of 68 and Class B with 25 students had a mean score of 80. Work out the mean score of all 40. Okay, so what we need to do is find the total for Class A, which will be the number of students multiplied by their average. And this will give us all the marks for Class A. So we'll do 15 multiplied by 68, which gives us 1020. We'll do the same for Class B. So multiply the number of students by the average mark that they scored, and that gives us the total number of marks that they've scored. Okay, we can add those totals together to give us the totals of all the both classes, which gives us this. And therefore the mean of both classes will be the total they scored over the total number of people in both classes, which is obviously equal to 40. Okay, so let's do that. Let's do 3020 divided by 40, and we get a mean mark of 75.5. The head of the department wants the combined mean score for both classes to be at least 79 marks. She decides to enter some students from Class C, each of whom scored 92 marks on the test. Work out the minimum number of Class C students that need to be added to raise the overall mean score to at least 79. Right, so how do we calculate the mean originally? So we did the total that all of Class A and B scored, and then we divided that by the total of all the people. Now, we're going to up the amount of marks scored by adding students, a number of students, let's call it X, and each of them will contribute 90 marks. So we're going to add on 92 marks. We're going to add on 92 multiplied by the number of students we're adding, and then when we divide to work out the mean, we're going to have to divide by the new students added on as well. And we want this to be at least 79. So what we're going to do next is multiply both sides by that denominator. Let's put it in brackets like this. So we get 79, 40 plus x. And then we can multiply out that bracket, 79 times by 40. 79 times by 40 is, okay, so 3,160. And then we need to do 79 times by x, which is just obviously 79x. Okay, great. So now let's solve this equation. We'll subtract 79 from both sides, 79x from both sides. So we'll do 92 minus 79, gives us 13x on this side. And then we'll subtract 3020 from both sides. So minus 3020, that gives 140. Great, so x needs to be greater than 140 divided by 13, which is 10.7. So we're going to need at least 11 students to be added. Perfect. Question 5. The students at Asbury Academy are either in Group X or Group Y. The ratio of the number of students in Group X to the number in Group Y is 5 to 6. 3/4 of the students in Group X study history and 35% of students in Group Y study history. Work out the ratio of the number of students who study history in Group X to the number who study history in Group Y. Okay, so we know that the fraction, let's work in fractions, of students that are in Group X is going to be 5 out of 11, because 5 plus 6 is 11, and X has 5 shares. So the number of students in group Y will be 6/11ths of the total. Okay, so the number of students, or the fraction of students who are in group X and study history, are going to be 5/11ths of the total times by, of those people, 3/4. So that will be the fraction of the total people at the school that study history and are in group X. Okay, so that gives us 15/44. And then the people who are in group Y and study history, well, that would be 6/11ths multiplied by 35%. Because again, 35% of the students in that group are going to be doing history. So we do that, whoops, like so. And that gives us 21 out of 120. Okay, so the ratio of group X to group Y, well, this is a fraction, so we can write it as a ratio, like so. Okay, and then what we're going to do is we're going to we're going to times both of them by 11. That should simplify things a little bit. So if I times this side by 11, we get 21/10, times this side by 11, and that will give us 15/4. Okay, nearly there. Let's times both sides by 20 now, because that should get rid of some of the fraction bits. So 15/4 times that by 20, which gives us 75. And then finally I've noticed that we can divide both of these by 3. So divide that by 3 to get 25. And divide this one by 3, and we get 14. Cracking, what a cracking question that was. Okay, expanded brackets, pretty standard stuff. Let's just start off with the first two. This is going to give us 2x squared. This is going to give us plus 10x minus x and minus 5. And we can simplify that by collecting the x terms together. We've got 10 minus 1, which is 9. And then we can reintroduce the third bracket. Just do it in our working as well, just to keep everything nice and neat, like so. Okay, so what I'm going to do first is I'm just going to times this bracket by 3. 6x squared, 27x minus 15. And then I'm going to times it by minus 4x. So minus 8x cubed, minus 36x squared, and plus 20x. Okay, so let's collect up the x cubes, of which there are minus 3. Let's collect up the x squareds, so that's going to give us minus 30 in total. Let's collect up the x's, that's going to give us plus 47. And then finally we've got minus 15, the only constant term. And that is job done. Okay, factorising. Let's look at the numerical parts. So the highest common factor there is 12. So we have to put a 12 out. And then looking at the x's, the highest common factor there is x squared. So we have to take that out. And then finally looking at the y's, the highest common factor there is y squared. So we've got to take that out. So what is left? Well, I've got to times this by to get that. Well, I've got to times the 12 by 3 to get 36. I've got to times the x squared by x to get x cubed, and I don't need to use times anything by the y to get y squared. There's a minus. What have I got times 12 by to get 48? It's going to be 4. The x squareds are done. But the y, I need to multiply by y squared to get y to the 4. Always check to see inside the bracket, are there any common factors? Because if there are, then it means you've not factorised properly. But this time there's not, so we are pretty confident that is all good. Okay, we've got inequalities on graphs. We're going to start off by sketching this line here. This is perfect. It's in the form y is equal to, or less than, but whatever, mx plus c, which is kind of what you always want when you're doing inequalities on graphs, because once I've plotted this, we know the intercept is 3, and for every 1 you go across, you have to go up 2, because the gradient is 2. And just be careful that 1 across is actually 2 boxes, because you can see down here the scale is a bit different on this side. So 1 across and up 2 looks like that, and then like that, and then like that. So that's helpful. We can draw that straight line coming all the way down like that. And then, because we want the y to be less than 2x plus 3, it means we want all the stuff which is below the line. But rather than shading that in, I'm actually going to shade the stuff we don't want. So we don't want the stuff above the line. So just get rid of all that. That should be enough. Okay, now a quick way of drawing a line when it's written like this is just imagining what happens when y is 0. So when y is 0, we get 4x equals 12, so x is equal to 3. So you can put a little cross on the x-axis at 3. And then imagine what would happen if x was 0, then it means that y is equal to 12, so which means that y is 4, so you can put a cross there on the y-axis at 4. And then you can join these lines up, like so. And there you have that straight line. Perfect. Okay, and now if we wrote it so that we have 3y is greater than or equal to 12 minus 4x, then you've got the y on the left, and this is saying that we want the y to be greater than 12 minus 4x, so we need all the stuff above the line, which means I'm actually going to delete all the stuff below the line. So I'm going to just scribble out all the stuff below the line. We're not going to be using that, so get rid of all that stuff. Yeah, everything below that line. Okay, that will do. Okay, so the region's kind of taking shape now. It says x is less than 3. Okay, that's nice and easy one. When it's x is equal to, that's a vertical line. And again, we want less than 3, which means to the left. So we're going to get rid of all the stuff to the right. So get rid of all that stuff, we don't need that. Okay, and then finally it says y is less than 5. So that's a nice easy one again. It's a horizontal line across at 5, and we're going to get rid of all the stuff we don't want because it says less than 5, so we're going to get rid of all the stuff above 5. Okay, great. And we can see what is left over is the region there, and we've labelled it, and we are good. Okay, simultaneous equations. So we need to multiply, we're going to do this one by 4 and this one by 5, and that's going to line up the y's. So timesing that top equation by 4 will give us 8x plus 20y is equal to minus 32. And the bottom one by 5 will give us 15x minus 20y is equal to, what's that going to be, 112.5? Let's just double check that, because I don't want to make a mistake. So that is 112.5, lovely. Okay, and now we're going to add these two equations together because the y's are lined up, but one's a positive, one's a negative. So when adding them together, we're going to cancel out the y's completely, which will give us 23x. And then what we're going to do is we're going to add that to minus 32. And that is going to give us 80.5. And then we're going to divide through. We're just going to hope, and we're going to hope for a nice number, because if we've got some really funky decimal, then we know we've probably made a mistake. 7 over 2, that is a nice number, 3.5, lovely. Now we're going to substitute into one of them. I'm just going to pick this one at the top. So that's 2x, and we know x is 3.5, so it's 2 times 3.5 plus 5y is equal to minus 8. Okay, so 2 times 3.5 is 7, so 7 plus 5y is equal to minus 8. And then minus 7 to both sides, minus 8 minus 7 is minus 15. Divide through by 5 and we get minus 3. So our final answer is 3.5 for x and minus 3 for y. And we'll box it up and we'll move on to the next question. Perfect. Okay, we've got indices here, and we can spot first off that they're all powers, the bases are all powers of 2. So 8 is 2 to the 3. So we'll write it like this. 4 is 2 to the 2. So we'll write it like this. And then we can multiply this denominator to this side. So times it by 1 just becomes 2 to the 5. Okay, now when we have a power and then bracketed, then raised to another power, we can times those powers together. So it becomes 2 to the 3x plus 3 times by 2 to the 2x squared minus 6x. And that's equal to 2 to the 5. Now when we've got 2's, or anything the same for that matter, and we times them together, we can add the powers. So this becomes 2, and then adding these powers together, we're going to get 2x squared. There's a 3x minus a 6x, which is minus 3x, and there's a plus 3. And that's going to equal 2 to the 5. Now we've got both sides of the equation is 2 to the power something, so therefore those somethings must be the same in order to make the equation equal. So we're going to set those two powers equal to each other. Now this is a quadratic, so we're going to want to set that equal to 0, so we're minus 5 from both sides. And then we're going to factorise that. So we've got a 2x, definitely going to be a 2x and an x. It's going to times to make minus 2. So if I put the minus 2 here, then that's going to give me minus 4x. And if I put a plus 1 here, that's going to give me plus x, which will add together to make minus 3x. So that's just done by inspection. Because the numbers are relatively small, it's probably quicker just to kind of do a bit of guesswork. So this means that x is minus a half and x is 2. And I think that is it. So there's the answer for that one and the answer for this one. Perfect. Okay, next question. We've got a train that travels a distance of 4.5 kilometers in 6 minutes. Work out the train's average speed in meters per second. So speed is equal to distance over time. And the distance is 4.5 kilometers. And the time is 6 minutes. But we want to change those units so that it's meters per second. Well, to change the top into meters, we just times through by 1,000. And to change this into seconds, we times through by 60. Because there are 60 seconds in a minute. So that's an S, by the way, not 5. So we need to do the calculation of 4,500 over 6 times 60. Perfect, gives us 12.5 meters per second. Okay, lovely question this. If I don't say so myself. AC is the diameter of the circle, so what I'm going to do is put a little dot in there to show that it goes through the centre. And BC is equal to 8 centimetres, so that's 8 centimetres up there. The area of the circle is 49 pi. So as we know, area is equal to pi r squared. So 49 pi is equal to pi times r squared. We can divide by pi on both sides. So we get that r squared is equal to 49. Not sure why I switched it around there, but hey ho. So r is equal to 7. Okay, so that's great. That's going to be useful, I'm sure. So that means the diameter is equal to 14 centimeters all the way across. And little circle for him here, because it goes through the center and we've got a triangle on top of a diameter, then that means that there's always going to be a right angle in this triangle, and it's going to be right there. So that's a right angle, and therefore we're going to use Pythagoras. So what we're going to do is we're going to say AB, which I'll call x, is what we're trying to find, squared plus the other short side squared will equal the long side squared, or the hypotenuse squared. So x squared will be 14 squared minus 8 squared. So x will be the square root of 14 squared minus 8 squared. And we will do that calculation by doing square root 14 squared minus 8 squared, and we will get to three significant figures 11.5 centimeters. Perfect. Okay, cumulative frequency. So nice easy 1 mark. We add up as we go along, so add on 26 gives us 38, add on 44 gives us 82, add on 40 gives us 122, add on 30, 152, and then add on 28 gives us 180. Lovely. Okay, now we need to draw that on the grid. So, being careful and mindful that we need to make sure that we plot at all the endpoints. So 50 is 12. So that will be right here. Just take into account what the scale is. Just really focus on getting that right. 38 is going to be here. And then 82 is going to be, so that's 80, 84, 86, no, sorry, 80, 84, 88, 92, 96, yes, every little square is 4. So 82 is halfway between a square. Sorry, I made this so difficult. 122 is halfway again. 152, however, is not going to be halfway. You've got 140, 144, 148, 152, and then 100 is 180, so that's nice and easy. Okay, so I would recommend connecting them up with straight lines rather than curves, as I've seen that the mark schemes favour straight lines more nowadays. So that is just job done. There we go. Okay, use your cumulative frequency graph to find an estimate. Classic. Well, half of 180 is 90. So I'm going to need to go across at 90, which is obviously halfway between 180. And then we're going to go down here. Okay, great. So that to me looks like 72. Yeah, 72. Okay, great. Is there another question? Yes. Okay, Mr. Asprey wants 80% of the students to pass the test. Use your cumulative frequency graph to estimate the minimum mark a student would need in order to be in the top 80%. Okay, well, if there's 180 people and they want 80% to pass, then the minimum mark would be the 20th percentile. So that basically means 36 students are going to fail. So if we go across and find out what the 36th student got, then that will be the pass mark. So 20, 24, 28, 32, 36 is this line right here. And that actually nearly works out. So come down here, that to me looks like it will be just shy of 60, but I think, yeah, 59 or 60 I'm going to accept as a fine answer. So we're going to go for 60 because it's nice and round. So that's the pass mark. Okay, find the equation of a line that passes through 3 minus 8 and is parallel to this line. So what we need to do is write this one in terms of y equals mx plus c. So I'm going to minus 2x from both sides, and then I'm going to divide through by 3, like so. So that's just another way of writing this, but this helps us find the gradient, because the gradient is what you multiply through by x when it's y equals. So now we need to do another y equals mx plus c for this new line. Now this new line has the same gradient because it's parallel to the old line, but we know it goes through this point here. So we're going to sub in for y minus 8, and for x we'll sub in 3. So minus 8 is equal to, and now minus 2/3 times 3 is minus 2. Add 2 to both sides gives us minus 6 is equal to c. So now we know the gradient and we know c, we could write the equation of the line. Like so. Okay. Does this line pass through this point? Well, if it does, then we could substitute that point into the line and it would work. So the y value would equal minus 2 times by the x value minus 3. So 198 would equal, so let's just put that into our calculator to make sure we don't make any mistakes, because lots of negatives going on over there. So minus 2 multiplied by minus 99 minus 3 gives us 195. So those are not equal, they do not equal each other, so therefore it does not. It doesn't pass through. Minus 99. Yeah, perfect. Okay, job done. Okay, quadratic inequalities. This shape is formed from 2 rectangles, so let's split it up. So this area here will be x times x minus 4, and this area here will be 7x. So the total area will be x minus 4 plus 7x, and we're told that is less than 88. Multiply out, like so. Collect up these like terms here to get plus 3x, and minus 88 from both sides, so that is equal to 0, or less than 0, should I say. Factorise. 2 numbers that times together to make minus 88 and add to make 3 are minus 8 and plus 11. Does the job. We want that to be less than 0. So the critical points are x equals 8 and x equals minus 11. Now, whenever you're doing a quadratic inequality, you've got to figure out which way round we are going to give our answers. So we've got minus 11, we've got 8 there. If we draw the quadratic, it looks like this. We want where it is less than 0, so we want below the axis. So we want the x coordinates which are in between minus 11 and 8. So we say that x is in between minus 11 and 8. But hold on, we have a non-negativity constraint. We can't have a negative x because x is a distance. In fact, this can't be negative. So x minus 4 needs to be greater than 0, which means x needs to be greater than 4 to stop that side being negative. So combining these two inequalities to get our final answer, that x needs to be between 4 and 8. Bosh. Okay, bounds. And it says, by considering bounds, work out the value of x to a suitable degree of accuracy. Well, that means we need to find the upper and the lower bound. So let's find the upper bound of x first. So that will be that c needs to be upper because it's on top and the fraction, we want the numerator to be big. And d also needs to be upper. But we're dividing by a, so we're going to want that to be small because the smaller number we divide by, the bigger our answer is. Okay, so the upper bound of c to one decimal place would be 4.55. The upper bound of d will be to two decimal places will be 2.055. And the lower bound of a will be 2.695, because that is right on the cusp of rounding up to 2.70 to two decimal places. Okay, right, so we can work out this, and we'll go to our calculator to do it. We will just type in 4.55 plus 2 times 2.055 over 2.695. And then we'll get that as a decimal, and that is 3.21, and we'll write out quite a few decimal places. That should do the job. Now, x is the lower bound. We need to find the lower bound of x. So we'll need c to be lower, we'll need 2d to be lower, and the denominator needs to be upper bound. So that would be 4.45 plus 2 times by 2.045 over 2.705. Okay, so that goes in, and in fact what we can do is just kind of change some of the numbers in here just to save a bit of time. Perhaps this will save time. What do you reckon? Does it save time? Yeah. Okay, great. So we can write that out as 3.15711.6. That should do the job. Now, a suitable degree of accuracy means that the lower bound and the upper bound all round to the same thing. So for example, if I was to round to the nearest 2 decimal places, then to 2 dp we would get we would not get the same thing. We would get this, or we would get this, or somewhere in between, depending on what the actual value is. So that is not a suitable degree of accuracy because it can be misleading. Whereas if we were rounding to 1 decimal place now, then yes, perfect. To 1 decimal place, that is all good. Because to 1 decimal place, we have 3.2 for the upper bound or 3.2 for the lower bound, which means no matter what, whether you're the upper or the lower or anywhere in between, it's always going to round to 3.2 to 1 decimal place. So the answer is 3.2 to 1 decimal place. Perfect. Okay, circle theorems. Wow, lots going on here. So the first one I can see is we've got this arrowhead shape, this quadrilateral which kind of makes an arrowhead. And when you see that, you know the angle at the circumference is half of the angle here at the centre. So this angle here will be 76 times by 2, which is 152. So in there, that's 152. Okay, perfect. Now, this is a radius and this is a radius, which means this triangle in here is an isosceles triangle. So this is isosceles. So therefore we could do 180 minus 152 and then divide that by 2 because the angle should be split perfectly on either side of the isosceles. So that gives us 28 over 2, which is 14. So that means this angle in here is 14. Okay, so this angle CBA, CBA is equal to 24 plus 14 plus 32, which is equal to 0, 7, so 70. And then on the other side, we've got this angle, which is the one we're looking for, which is angle ADC. Well, you can see we've got a cyclic quadrilateral there. So opposite angles in a cyclic quadrilateral add to 180. So we have to do just 180 minus its opposite angle of 70 to get 110. Cracking question there. Okay, chord theorems. Now, the important thing to note about chord theorems is that whatever your equation you create, it always has to involve the intersection point for all four of the chords. So what I'm saying is that AP multiplied by BP is going to equal CP multiplied by DP. So you can see that I've put there's P in every single one of the chords, and that's important because what we don't want to do is we don't ever want to use this distance in our multiplication, and that's a big mistake which some people make. So following this exact formula, AP is x plus 2 times by BP. Well, BP is AB, so this bit, and this bit all together. And that's equal to CP, which is all of that. So that will be 3 plus PD, which is 2x minus 1. And then we're going to multiply that by dp, which is just 2x minus 1. Okay, right, there's our formula. So now we need to just do a little bit of simplifying. So this is actually going to be 8 lots of x plus 2, because this bracket here is just 8, because the x's cancel, and you've got 6 plus 2 is 8, so just times it by this. And over here, we're going to have 2x plus 2 needs to be multiplied with 2x minus 1. Okay, so we can multiply this out to get 8x plus 16. And this comes out to be 4x squared minus 2x plus 4x minus 2. So we can collect the x's on that side up. So minus 2 plus 4 is plus 2. And then we can bring it all over to one side because it's quadratic, so we want to equal it to 0. So take away 8x from both sides gives us minus 6x, and take away 16 gives us minus 18. Now, whenever we've got a quadratic we need to solve, if we can divide through, that's going to be super helpful just to make our numbers smaller. So we can divide through by 2. Okay, so a 2x one, normally I'm just going to do it by inspection because it's definitely going to be a 2x and an x. And they've got a times to make minus 9, so it's probably going to be 3 and 3. So if I put a minus 3 over here, that's going to give us minus 6. If I put a plus 3 here, that will give us plus 3, and minus 3 plus 3 is minus 3, which is exactly what we need. And they times to make minus 9, so that is good. So x here is equal to minus 3 over 2, and x here is equal to 3. Now we've got that non-negativity constraint as well. All of these distances must be greater than 0. So that means that we can't have minus 3 over 2, because then this one here would be negative, which we're not allowed. So therefore we have to reject that solution, and this is the only correct solution. Okay, set theory, and it says the universal set is 1 through to 15. So those are all the elements that we're going to be considering. And then we've got two subsets, which are A and B. And it says explain why A intersection B does not equal the empty set. Well, if it doesn't equal the empty set, then it means there must be something in it. And what is in it is 3, because 3 is in both A and B, so therefore it's therefore it is therefore it is in the intersection. That's what I was trying to say. So yeah, that's good. Basically, that explains it. So I don't need to really do anything else. Okay, next it says list the elements of the union. So the union is anything which is in A or B or both. So straight off the bat, all of the elements of A are in the union of A and B because they are in A. And then so are all the elements of B as well. Now we're not going to write 3 again because we've already written that once. But 6, 9, and 12 and 15 are all in the union because they're in B. Okay, great. Now it says a third set is a subset of the union. So we're picking from these numbers here. And it says that A intersection C is equal to 13. Okay, so therefore we know that for C, let me just zoom out so we can see the top bits as well. Okay, so yeah, so we know for C then that it must contain 13 because C 13 is in A and C, which means it's in both A and C. So therefore it's definitely in C. Okay, but what that also means though is that all the other elements at A are not in C. So 2, for example, if that was in C, then it would be in the intersection of A and C because it's definitely in A. But it's not in the intersection of A and C, so therefore it can't be in C. So we can eliminate 2. That's not in. Nor is 3. Nor is 5. Nor is 7. Nor is 11. And 13 is good. Okay, now the next condition is that it says that B intersection not C is equal to 3 and 12. Okay, so therefore 12 is not in C because it's in the intersection, so we know that for certain. Now, all of these other elements here, these must be in C because if they weren't in C, they are in B, so therefore they would be in B and not C. But because they are in C, it's why they're not in this set here. So we can say we've also got 6, 9 and 15. And that is job done. Okay, we've got a survey of students records the extracurricular clubs they belong to. Got D, L and T. Okay, so we always like to start in the centre, and it says that all 3 clubs is X. So we'll place X right in the centre there, and also it says none of the clubs, so let's just tick that, none of the clubs is 5, so we put 5 on the outside. Okay, so next, drama and language only. So drama and language only goes in here because these are the people that do drama and language and they don't do tech. And that specifically says there's 14 in there. Tech only is 9, so that is this region here, that's tech only. And drama only over here is 5. Okay. So next it says that drama total is 30. So this circle here needs to add up to 30. So at the moment we've got 19 plus X. And then plus something in here, let's call it Y, needs to add up to 30. So Y is equal to 11 minus X by subtracting the 19 and then subtracting the X. So in here we have 11 minus x. Okay, great. Now let's look at tech total. So there's only one missing. So let's look at this one here. Tech total is 24. Again, let's just call this y, just to help with our working out. So for tech to be total, we have to do 11 minus x plus y plus 9, and all of that must equal the total of tech, which is 24. So minus x and plus x will cancel. So 11 plus 9 is 20. So it's y plus 20 will equal 24. So y must equal 4. So we can put a 4 in here. Okay, great. So the next one is languages only. So that one is, of course, this circle right here. And we know that adds to 26. So we've got 14 and 4 makes 18, plus x, plus this unknown bit here. We know that's going to add up to 26. So minusing 18 from both sides gives us x plus y is equal to 8. So therefore y is equal to 8 minus x. So this one here is 8 minus x. Well, that was actually quite tricky. Okay, so that's the Venn diagram done. And now it says given 54 students were surveyed, find x. Well, we need to add up all of the terms in here. So we have to do 5 plus 14 plus 8 minus x, and then plus 11 minus x plus 4, and then plus 9 plus 5, and that's equal to 54. Okay, so let's just do all the numerical ones first. So we have 5 plus 14 plus 8 plus 11 plus 4 plus 9 plus 5. That's equal to 56. Okay, and then we've got minus 2x and a plus 1x. So that's minus x is equal to 54. So clearly x must equal 2. Okay, perfect. And then it says a student is chosen at random who belongs to drama but not tech. Okay, so let's just figure out who those people are. They belong to drama but not tech. So it must be these people that we're talking about. They belong to drama but they're not in the tech bubble. Find the probability that this student also belongs to the language club. Well, if they also belong to the language club, then they are these people here. So there's 14 people out of a total of 19. So the answer is 14 out of 19. I didn't mean to write x there. Whoops. So 14 out of 19 is the answer to that question. Okay, classic question this, rearranging formulae. There's a square root that covers the whole right side, so we're going to square both sides to get rid of that. That's going to give us mx plus 4 all over 5 plus x. We're then going to multiply through by the by that denominator, like so. Then we're going to expand out this bracket. Then the overall goal is to get all of the x's onto one side. So we can pick either side here. Let's just go move them all over to this side. So this one comes over and it's going to have to take away to move it over, and this one needs to move over, and again we have to take that away as well. So we have 4 minus 5y squared. We can then factorise on this side to get x then times by a factor, and then the final step is to divide through by that factor bracket which we've created, and then we have x on its own. Whoops. We're dividing through by y squared minus m. Perfect, there we go. X is on its own. It doesn't occur in the equation, which is not allowed to, and that is good. Okay, proof. So it says, using algebra, prove that any three consecutive numbers, so the consecutive numbers I'm going to choose are n minus 1, n, and n plus 1. You could do n plus 1, n plus 2, but I often find that using n minus 1, you just get more things cancel out and it just becomes slightly easier. Anyway, it says the sum of their squares. So we're going to add together the squares of each of these, and then we're going to minus the product, which means to multiply, the smallest, which was n minus 1, and then the largest, which was n plus 1. Okay, is always, so we'll see what that equals then. Let's figure out what this equals. So on the side, I'm going to do n minus 1 squared, which is n minus 1 times n minus 1, which is n squared minus n plus 1. So that's n squared minus 2n plus 1. And if I were to do n plus 1 all squared, then that's n plus 1, which is going to give us n squared plus n plus 1. So that's n squared plus 2n plus 1. Okay, so we're good to go. Let's take this one, which was this, and then we're going to add on n squared, and then we're going to add on the n plus 1 all squared, which was this, and then we're going to minus, and this is where mistakes often happen when we take away a large term like this. But let's first do this bracket. We'll get n squared and plus n, and we'll get minus n and minus 1, so that's n squared minus 1. So I'll put it in brackets like this because so many people forget to apply the negative to that minus 1 there, so we're not going to forget that. Okay, let's collect up. So how many n squareds have we got? We've got 1, 2, 3, and then we're going to minus 1. So that's a total of 2n squared. Now, what I said about the cancelling, that minus 2n is going to cancel with that plus 2n. Okay, so that's great. And then we're going to get numerical terms, we're going to get, constant terms, we're going to get 1, add 1, and then minus 1 is adding 1. So we're adding 3 ones, so plus 3. Okay, now, is this 2 more than 2 times the square of the middle number? Well, I think it is, yes, because this is exactly 3 more than 2 times the square of the middle number. I always find these questions a bit odd, like how do you actually show that afterwards? But I guess we just say that 2n squared plus 3 is 3 more than 2 times the n squared. Perfect. That does the job. Okay, these vases are geometrically similar, and it says that the ratio of the volumes of the vases. So if we know the ratio of the volumes of the vases, then we can straight away find the scale factor for the linear ratio. So what we can do is we can, to find the linear ratio, we can take the square root, sorry, the cube root of the volume scale factor. So it'll be the cube root of 27 to the cube root of 64, which will be 3 to 4. Okay, and then that will allow us to work out the area ratio, because the area ratio is the square of the linear ratio. So that'll be 3 squared to 4 squared, which will be 9 to 16. Okay, great. Now, which is the bigger one? Q is the bigger one, and it says the surface area of Q is 160 more than the surface area of the vase. And in fact, we want to calculate the surface area of the vase Q. So let's call that X. Okay, so if Q area, if the area of Q is equal to X, then what is the area of P going to equal in terms of X? Well, Q is the bigger one, so P is smaller. So in order to get P, we'd have to times by 9 over 16. As that's the scale factor in terms of area. So it's 9 to 16. So therefore we would divide by 16, then times by 9, and that will give us the area of P. And then it says that so the difference between them is 160. So if I take the larger one, X, and I minus the smaller one, then this will give me the difference between them, which is 160. Okay, so what we need to do then is figure out what 1x minus 9 over 16 is, and that will be 7 over 16. So we'll have 7 over 16x is equal to 160. And then we can divide through by that 7 over 16, and that will give us x, which is the surface area of the vase Q, which is exactly what we're trying to find. And we just need to write that now to 3 significant figures. So that's 366 centimeters squared. Perfect. Okay, so algebraic fractions. First thing you notice is that we need to divide before we subtract because of BIDMAS. So if we're dividing fractions, it's good to write both of them as a fraction. And when we are dividing, it's the same as multiplying, but flipping the second fraction over. So we get this like so. Okay, and then afterwards we're going to subtract. But yeah, like I say, we're going to do that afterwards. But I'll write it out here just to keep it nice and consistent, so that we're always writing down the whole expression. Okay, now on the side, I'm going to do this factorisation of 4x squared plus 4x minus 15. So we've got a, b, and c. Now this is how I factorise quadratics. I look at the a times by the c, which is 4 times by minus 15, which is minus 60. And then the b term is equal to 4. So we need to find two terms that times to minus 60 and add to make 4. Now while I'm thinking about what those are, I'm going to write 4 because the a term is 4. So we're going to write 4x, and then all divided by 4. Now all we need to do now is just figure out those numbers, the two numbers that times to make minus 60 and add to make 4. Now obviously I'm stalling because I'm trying to figure out what they are. And but I know what they are. Obviously, I'm but one plus 10 and minus 6. Yes, that does the job. Plus 10 and minus 6. And then we've just got to divide these brackets by 4. Now we can't divide either of them fully by 4, but we can divide each of them by 2, which will do the same thing. So dividing them by 2 gives me 2x plus 5, and divide this one by 2 gives me 2x minus 3. Sorry. And we've divided through by 4 because we've divided each of them by 2. So overall we've divided by 4. Perfect. So that's the factorised form. Okay, so I can now rewrite this. In fact, just to save a bit of time, rather than I'm just going to delete it, I'm going to write the factorised form in here, which is 2x plus 5, 2x minus 3. So now this, we can imagine this as a bracket like this, and it allows us to then cancel that bracket with this one down here. So this fraction over here becomes 5 over 2x plus 5. And then we're going to subtract 3x plus 7 over, and we're going to factorise this. That's the difference of two squares, because both of these two are squares, and the difference part means because there's a minus sign there. So we take the square root of each, and we write one bracket with a minus and one bracket with a plus. Okay, now in order to subtract fractions, or add for that matter, the denominators need to be the same. Now, the denominators are similar, but this one is 2x minus 5 times bigger. So what we can do is we can multiply both sides. We can multiply top and bottom of this first fraction here by 2x minus 5. And that won't affect the fraction's value. It's equivalent because we're timesing top and bottom by the same thing. But now we've got a common denominator, which allows us to add the fractions. So on the bottom, we've got this common denominator of 2x plus 5, 2x minus 5. And if I multiply out this bracket here, I get 10x minus 25. And then I'm taking away this whole thing. And again, this is a big mistake that students make, is they forget. They're all very well and happy to take away the 3x, but they forget to apply the negative to the final term as well. So we should get this. And then this can be simplified because we can collect the terms on top to get 7, and minus 25 minus 7 is minus 32. And then we can check, does that have a factor on the top and bottom? No, that top can't be factorised, and it's not on the bottom, so therefore that is the final answer. That's as simplified as we can get it. Perfect. Okay, I thought this question was quite interesting. The volume of the cylinder is x centimetres cubed. Okay, so that means that we know that x is equal to the volume of the cylinder is pi r squared h. Okay, that's it, yeah. The volume of the sphere is also equal to x, and that is pi r cubed. No, it's not. Sorry. It's 4/3 pi r cubed. Now the r here is actually 2 lots of r. So it looks like this. And then when we cube 2r, we get 8r cubed. Times by 4/3 is going to be 32 over 3 pi r cubed. Because again, 2 cubed is 8, times by 4 is 32, and then over 3 means 32 over 3. And then the r get cubed as well. Okay, so if these are both equal to x, it means we can set them both equal to each other. So we can say that pi r squared h is equal to 32 over 3 pi r cubed. And we can cancel a pi from both sides, and we can cancel an r squared from both sides, which leaves just r there. So we get that h is equal to 32 over 3r. Okay, so that's got to be useful, but obviously we can't do anything in terms of solving yet. We need more information. So it says that the surface area of the cylinder is also equal to x. So the surface area of the cylinder is going to be 2 pi r squared, because you've got a base and a lid, and then the bit which you wrap around the cylinder has a height of h, and it has a width of the whole way around the cylinder. So it's the circumference of the cylinder, 2 pi r, times by h. Okay, now what are we going to do? Okay, so now we know that we can sub h in here. We also know it's equal to x, and we also know that x is equal to this, which doesn't have a h. So that's going to be helpful in us being able to find r. Okay, so we can say that 32 over 3 pi r cubed is equal to 2 pi r squared plus 2 pi r h, which we know is 32 over 3r. Okay, great. What a question. So we can divide everything through by pi. I'd be really interested if anyone solves this in maybe a more efficient way, but I think this is good. 2r squared plus, this is going to be 64 because 2 times 32 over 3 and then r squared. Okay, great. Let's times through by 3 just to get rid of that horrible fraction. We don't need that. So we get this, which is nice. We can then divide through by r squared. So you both go and you turn into just an r. So we get 32r is equal to 70. So r is equal to 70 over 32. So a good test of algebra skills here. Now we can work out h by looking at this box and this box here. So h is equal to 32 over 3 times r, which we know is 70 over 32. So the 32s can cancel, which leaves us 70 over 3, and that might be my favourite question that I've created on this paper. Lovely. Okay, another tricky question. So we've got this ratio situation of all the dimensions. So we can just nominate this to be 2, this to be 2, and this to be 5. And because we're working out an angle, it doesn't really matter what the exact size of the sides are. All that matters is the proportions, which is correct because it fits the ratio which we've been told. So h, well, if you're trying to find the long diagonal of a cuboid, then there's a really quick way of finding it, and that is just by doing the square root of all 3 dimensions squared and added together. So in this case, 2 squared plus 2 squared plus 5 squared, which gives us the square root of 4 plus 4 plus 25, which is the square root of 33. Yep. Okay, and then if we draw a line directly down to the base, which has a distance of 2, and then a line connecting up that line across the base, then this is the angle we're looking for. So that angle would be sine inverse, because we have the opposite, which is 2, and then over the hypotenuse, which is this long diagonal, which we said was root 33. Okay, so we do, on our calculators, inverse sine of 2 over square root 33. And that just gives us 20.4. Perfect. Okay. Okay, now let's go on. Okay, it says that M is on the line AD such that AM to MD is 3 to 2. Okay, so let's split up that line AD. It's no longer 5. Well, I mean, it is 5, but what I'm trying to say is that if I put M here, then A to M could be 3, and M to D could be 2, because that adds up to 5, and it's in the ratio of 3 to 2, so that's good. And it says, given that the surface area of the cuboid is 432 centimeters cubed. Well, that is now going to allow us to actually work out what the actual lengths are, as opposed to just the ratios of them. Because we can work out the surface area, and let's focus firstly on this square here. Now, I've said that's 2 by 2, but we don't know if it's exactly, it could be 4 by 4. So let's just use x like this, so 2x and 2x. So that area is 2x times 2x, which is 4x squared. And in fact, there are two squares just like that, because there's obviously the one over here as well. So what we'll do is we will times that by 2. So that will give us 8x squared. Okay, now all of the other 4 sides are actually exactly the same, because they're all 2 by 5. Or because we don't know the exact lengths, we'll call it 2x by 5x. So the yellow ones are all the same, and there's 4 of them. So it'll be 4 times by 2x times by 5x, which will be 10x 40x squared. Okay, so the surface area then is going to equal all of those added together, which will be 48x squared, which we know is 432. Divide through by 48 gives us 9, so x must equal 3. Okay, that's great. So that basically means that I need to just times all of the side lengths by 3. Because they're all, again, the ratio which we were using there was 2x to 2x to 5x. We found that x was 3, so this is going to be 6, 6, and this whole distance along the top will be 15, which means this bit in here will be 9, and this bit in here will be 6. Like so. Okay, and it says find the length MH. Okay, great. So what I can do is I could just draw a line that goes from here to here. Just do that again. Nice straight line that goes from here to here. We can draw a line down and then a line across. Now once again I'm going to use my little cheat here, and that is I'm just going to imagine that the cuboid has now been, I'm just looking at that bit on the left. So let's look at all 3 dimensions. So the height of this little mini cuboid is 6, going across is 6, and coming this way is also 6. So in fact, to work out the line there, the distance, it will be the square root of 6 squared plus 6 squared plus 6 squared, which will be, there were 3 36s there, so 108, so it's the square root of 108, which is 6 root 3. Okay, we could give it as a decimal, which is 10.3 or 10.4. Okay, perfect. Obviously you can do it the more old-fashioned way, which is by working out this distance here, along here, and then afterwards doing another Pythagoras to work out the line. You should get the same answer. Give it a go. Okay, so completing the square, it says find the values a, b and c such that we have 6 plus bx minus 2x squared is equal to blah 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 blah. Okay, so rather than trying to complete this square, which would be quite tricky, and then comparing them, what we could do is we can expand this one, which would be easier, and then compare them. Keep that one the same, and then we're going to get c minus a, and then x minus 1 all squared is x squared. We'll get a minus 1x and another minus 1x, so minus 2x, and we get minus 1 times minus 1, which is plus 1. Because of course when we do that we have to write it out like this and square it. Okay, so now we can write this as c minus ax squared. Minus a times minus 2x is plus 2ax, and minus a times 1 is just minus a. Okay. Now let's write it in a similar way where we can compare the coefficients. So I'm going to write c minus a, I might actually put that in brackets, and then I'm going to write the plus 2ax, and then I'm going to write the minus ax squared. And this way we've got the constant terms, which are the terms without any x's. We've got the single x terms, and then we've got the x squared terms. So we can compare them because they must be the same on each side in order for it to be equal. So clearly from the greens we can see that a must equal 2 because you've got minus 2x squared and you've got minus ax squared, so a must be 2. Okay, now we can look at the yellows. So we've got b is equal to 2a, which is 2 times 2, so that's 4. And now we can look at the green, the blues, and that will be 6 is equal to c minus a. We know a is 2, so c minus 2. So add 2 to both sides and we get c is equal to 8. So right, there we have it. We've got a is 2, b is 4, and c is 8. Perfect. Okay, find the inverse function of a quadratic. Really popular question, this. So what we need to do is we need to write it as y equals, and we're going to complete this square. So we're going to take a 2 out so that it's just x squared, and that'll be minus 10x, and then I'm going to leave the 51 outside because we don't need to take a 2 out of that. Now looking inside that square bracket, if I want to complete that square, I need to half the b term, so half of minus 10 is minus 5, square that bracket, and then take away minus 5, which is that half b term again, all squared, like so. So that is the process for completing the square. We then can just evaluate this term here. This minus 5 squared is 25, but then we're taking it away, so we're taking away 25. And then we need to multiply through by 2 now, so it becomes 2 lots of this bracket, and then we get minus 50 and then plus 51. So we get y is equal to 2x minus 5 all squared plus 1. Brilliant. Okay, now comes the x-y swap. And we do that to find the inverse function. We swap the x for y, the inputs for the outputs, they swap over. So we get x is equal to 2 lots of y minus 5 squared plus 1. And then to find the inverse function, we need to rearrange for y. So we do x minus 1 is equal to 2y minus 5 squared. We divide through by 2 to get y minus 5 squared. We then square root. So we get the square root of x minus 1 over 2 plus minus is equal to y minus 5. And then we move this over there and it's going to become a plus. So plus, so positive 5 plus minus the square root of x minus 1 over 2 is equal to y. Okay, great. Now, there's one more thing we have to do when we find the inverse of a quadratic. We have to look at the domain that was given, and this time it says that x needs to be less than or equal to 5, which means that all of the things that you put into the function are smaller than 5. So therefore, all the things that come out of the inverse function also need to be smaller than 5. So what must I choose in order to keep my function, or my inverse function, to be smaller than 5? I must say that it is minus the square root of x minus 1 over 2. And that is the final answer. Okay, it says the point minus 1, 6 is a minimum point on the curve for this equation where k and m are positive constants. Find k and m. Okay, so if this is a minimum point, then it must lie on the curve, which means it must satisfy that equation. So we can sub in and it should work. So if y is 6, then we can have 6 equals k x squared, which will be minus 1 in this case, minus m over minus 1. So this gives me 6 is equal to k, because minus 1 squared is just 1. And if we are dividing by minus 1, that makes m negative, but there's a negative there, so 2 negative makes positive, so it's plus m. Okay. Right, can't take that any further, but that will be useful because we're going to get a simultaneous equation. Now the other bit of information is the fact that it is a minimum point, which means that the derivative at that point is 0. So let's find dy by dx, but first let's write it in a form which we can differentiate, and that is by taking this x here and writing it as a negative power as it is on the denominator, so to the power of minus 1. Now we can find dy by dx. We get 2kx plus, because the minus 1 will times by the minus here, m, and then we have to drop the power down by 1. Now, I haven't really explained this, but m and k are constants, so we don't need to do any sort of differentiating of them. We only differentiate the x's. So that's why here the x squared, the 2 came down, and then we dropped the power down by 1. And then here with the x to the minus 1, again the power came down, and then we dropped the power down by 1. So we just differentiate the x's. Okay. Now what we're saying is this is equal to 0 when we're at the minimum point. So when x is equal to minus 1, dy by dx is equal to 0. So subbing in, 0 is equal to 2k minus 1 to the power of 1, which is just minus 1, and then plus m minus 1 to the power of minus 2, like so. Okay, so this is going to give us minus 2k, because the minus 1 will make that negative, but minus 1 to the power of minus 2 is actually just 1, so that's just going to stay as m. Okay, so that is our second equation. Now we just need to solve these two simultaneously and we should be good. So what I'll do is I'll just write this one directly below, like that, and then we will subtract the two equations. So this is going to give us 0 minus 6 is minus 6, minus 2k minus a k is minus 3k, and then m minus m is 0, so they cancel. So dividing through by minus 3 gives us k is equal to 2. And then over here, if k is 2, it's clearly obvious that m is 4. So that is job done. Nice question, that. Okay, the displacement s in meters of a particle p from a fixed point O at the time t seconds is given by this formula here. Okay, find the times the particle is at rest. So we need to find the velocity, and the velocity is the derivative of the displacement with respect to time. So differentiating this, the 3 comes down, and then we drop the power down by 1. The 2 comes down, times by minus 15 over 2 gives just minus 15, and then we drop the power down by 1. And this is 12t to the 1, so the 1 times by the 12 just gives us 12, drop the power, so the t 0 is just 1. Times it by 1 is going to give us just 12. Okay, so we've differentiated, and we want to find the times it's at rest, which means the velocity is 0. We can divide this quadratic through by 3, like so, and then we can factorize it to get t minus 1, t minus 4 is equal to 0. So t is equal to 1 and t is equal to 4. Perfect. So not too many dramas there. Okay, part B is quite challenging actually. I feel a bit bad for putting it in the paper, but hey, good. Why not? Let's challenge ourselves. So it says find the distance travelled by the particle in the first 4 seconds. Well, what we know is that it's at rest when t is equal to 1 and when t is equal to 4. So if we were to, it's a good idea just to plot the velocity time graph of this object. So it's going to start off going at a positive 12, and then it's going to be at rest at 1 and then at rest at 4, like so. So the velocity time graph is also, it's a quadratic, so it's going to take this shape like this. Okay, so what it means is that for this part the velocity is positive, so it's going to be moving forwards. And for this part of the journey, because it's below the axis, the velocity is negative, which means it's going to be moving backwards. So the path of the object is going to be moving forwards for a certain amount of time, and then it's going to start moving backwards for a certain amount of time after that. Perhaps it's longer, I don't know. Or it's longer time, but for how much distance it travels, we don't know yet. So let's look at the first part of the journey when it is moving in the positive direction. And what we could do is substitute in t is equal to 0, because that's where it starts, and into the displacement formula. So when t equals 0, the displacement, subbing into this formula here, we're going to get 0. Fine. So it hasn't moved at t equals 0. And then when t is 1, it would have moved forwards. And how much would it have moved? Well, subbing in t equals 1 into here will give us 5.5, as the calculator says. Okay, great. Now we are going to be moving backwards. So let's see how far we've travelled going backwards. So let's find what the displacement is when t is equal to 4. So what we could do is we could do 4 to the power of 3 minus 15 over 2 times by 4 squared plus 12 times by 4. And that gives us minus 8. Okay, interesting. So what that means is that we start at a position of 0, we move forward to 5.5, and then we move all the way back to minus 8. So how much distance has this object travelled? Well, it's gone 5.5 and then a distance of from 5.5 to minus 8. So it's done 5.5 in the positive direction in green, and then in the yellow part we've gone from 5.5 away from 0 all the way back to minus 8. So that is a gap of 13.5. So it's done 13.5 distance in the yellow bit, because it's gone from a position of 5.5 to a position of minus 8, which is a gap of 13.5. So overall, add these two together and we get 19 meters is the answer. And if you got that right, very, very well done. And that is the end of the paper. If you enjoyed this paper, then definitely check out my live revision session, where I have 2 predicted papers that I'm going to be going through, and 2.5 hours of me doing that. You get the recording, work solutions and video solutions to all 60 questions. But also remember that you should revise thoroughly, and I wish you the best of luck in your exams. Subscribe, tell a friend to share the channel, and to also subscribe, and bye for now.